Well, we're beginning to look at the circular and periodic functions, trigonometric functions. And brings us to the famed unit circle. So the unit circle is on the coordinate plane. It's got a radius of 1, and the terminal side lies along the x-axis or the origin. So here is the terminal side. And it, from the origin to any point on the unit circle, would have a radius of 1. In other words, this right here has a value of 1, which would be like the hypotenuse of a right angle that we're going to just kind of sketch in here in just a second. In fact, right now, from point P, if we were to draw a line straight down to the x-axis, we can see that this is the radius, then is the hypotenuse. So if we go back to our cosine functions, and here's theta here. So cosine is adjacent over hypotenuse. And so this point here, and if is this measure, and so if the hypotenuse on a unit circle is always going to be equal to 1, and the terminal side is lying on the x-axis, then the cosine is going to equal the value of x on the coordinate plane. Now think about the sine. Sine is opposite over hypotenuse. And of course here would be the opposite side, and a hypotenuse of 1, opposite from theta, opposite from angle theta. And that's going to relate to the y-coordinate on the coordinate plane. So when we're talking about the unit circle, when we're asked to find the sine or the cosine, well, the cosine is going to equal the x-coordinate, and the sine is going to equal the y-coordinate. And so here we find that the terminal side of angle theta in standard position, that means it's lying on the x-axis, intersects the unit circle at P, where the coordinates of P are 3/5 and -4/5. Find the cosine of theta and the sine of theta. Well, the cosine is just simply going to equal that x coordinate. So the cosine of theta in this example equals 3/5. And therefore then the sine of theta, which is equal to the y coordinate, is going to equal -4/5. Okay, we do wish it was all this easy, but it's not always. But hey, have fun while it's here.